Okay, so in the last lecture, I showed you the answer to a supply and demand problem. Now, I thought that I'd show you a slightly trickier problem now. Now, what's tricky about it is the first part. Once again, we're talking about quarter-pound burgers. So the first part is about quarter-pound burgers, just like in the last problem. But the second part is about tons of meat. So the problem is that you can't create a supply function which is in quarter pounds and a demand function that is in tons. So what we're going to do, we do have the conversion. A ton is 8,000 quarter pounds. But what I'm going to do here is we got to translate both of these into the same unit. And I'm going to use the unit of this problem is pounds. Now, problems, you're lucky that all of the suppliers are also working in dollars as well as the sales. If you were getting your meat from, say, Mexico, then instead of dollars, we might be getting it in pesos. And that, so we'd have different units both for the money and for the quantities. I'm going to keep it simple. We'll do dollars for both. But it's quite possible. It's very common nowadays to be having to have a supplier in one country, either that's doing pesos or euros or whatever the currency is in China, and you got to pay in that part, and your quantities might be English and metric, and it just can get incredibly confusing. So we're going to use as a unit pounds. So I got to, oops, that's not what I want to happen. I'm going to get, so it's $1. So first I'm going to do part A. Once again, it's price quantity table for the demand function. No totals for that. So instead of $1, a quarter pound, if $1 for a quarter pound, to get a pound, we're going to need 4 times $1. So $4 for every pound of meat you sell. And how much will you sell? Well, you'll sell 5,000 divided by 4 pounds of burgers. So we get the $1. Instead of $1, we have $4, and we'll sell 5,000 over 4 pounds, which is 1,250 pounds of burger meat. Now, the next one we got to do the same thing. It's 4 this times 75 cents is $3 of 4. So if you charge $3 for a pound of burgers, just ignore that. Okay, it's uploading the last lecture. We'll sell 8,000 over 4 pounds of meat, which is 2,000 pounds of meat. That's a ton, by the way. We're going to use that up here. So we'll sell a ton of burgers. Now, we're going to do the same math as before with these modified prices and quantities. Okay, because we're doing it all by the pound. Okay, so that's going to give us 2,000 minus 1,250 divided by 3 minus 4 will be this slope. And it's good that it's negative. Don't lose that negative sign. Okay? Positive slopes don't make sense in demand functions. Now, we'll take. Now I'll just plug in. Let's use 3 and 2000 for this one. So I'm going to take 2000, the quantity, equals negative 750 times 3, the price. Because at $3 we sell 2,000 pounds, and that's plus intercept. So 2,000 equals 3 times negative 750 is negative 2250 plus intercept. So if I got this right, we'll add 2250 to both sides, and that'll give me 4250 is the intercept. So according to this, my demand function for the price in pounds and the quantity in pounds is negative 7050 times the price of a pound plus 4250. And once again, the intercept is positive, the slope is negative. You always want that to be true. So what does that do for us? Well, let's first check and make sure this makes sense. So I'm going to plug in $4, and I better get $12.50. So I'll get negative 750 times 4 plus 4250, and that gives me $12.50, so that's a check. I'm tired of using my finger to check things. We'll just do it that way. Now, so that's part A. We know our demand function. Now, part B, we're going to have to translate. So here's part B. And we're going to build the price and the quantity and the total table. Now, a ton is 2,000 pounds. So we can get the ton. The quantity is going to be 2,000 times 1, or 2,000 pounds. Let's just say 2,000 pounds. 2,000 times 1 equals 2,000 pounds. The total we'll spend on those 2,000 pounds, it says, is $1,000. So how much are we spending per pound? Well, once again, you take the total price and divide it by the quantity you're buying, and that gets the price per item, which is 50 cents a pound. So the cheapest supplier is selling us the meat for 50 cents a pound. Now the other quantity, the next cheapest, also has a ton. So it's going to be also 2,000 pounds. And it's giving us the total he spends, pays for it, 1,500. So this is the total. And I don't really care what his price is per pound, because it's not relevant to the answer to this problem. The real thing that's going to be relevant is the quantity, 2,000 plus 2,000 pounds. Oh, come on. 4,000 pounds. And the total we're spending to get that 4,000 pounds is 1,000 plus 1,500 is 2,500. So the price of a pound from buying from both the cheapest and buying at the cheapest and next most expensive guy is 2,500 divided by the 4,000 pounds. So 1 pound is going to be, let's make this $6.62.5. Okay, so now we're going to use this guy and this guy. We're going to use that price quantity pair And we're going to use, there's got to be prices and quantities to get equilibrium. Because if we use anything else like totals or we do it in different units or something, they both don't end up on the same graph. They never hit each other. To find an intersection, you have to be using the same units and on the same graph, right? On the same. Okay. So, standard math now. We'll take change in quantity, 4,000 minus 2,000, divided by change in price, 0.625 minus 0.5. Let's put zeros in for our readability. And the result is a slope, a positive slope, that's important, of 16,000. It's a big slope because a dollar change, we're dealing with changes of around 10, 15 cents. A dollar change and big quantities of meat. A dollar change really would make a huge change in the amount of meat you can buy. Okay? What would happen is if you add a dollar, then people would start showing up from all over to try to sell you meat. Okay, because you're willing to spend a lot more. Now, they'll be grinding up their steaks and whatnot. So we got the slope. To get the intercept, we're going to plug in, let's plug in the easier fraction, 2,000 and 0.5. So we'll take 2,000 pounds equals the slope, 16,000 times 0.5 plus the intercept is going to be our supply function. Okay, well, this is going to be 2,000 equals 8,000. Oh, by the way, this should be 16,000, not 160,000 there. Have to make sure you don't copy wrong. 8,000 plus the intercept. We subtract both sides by 8,000. And that gives us negative 6,000 is the intercept. So, our supply function, S of P, equals 16,000 P in dollars minus 6,000. Now, what we're going to do here is part C. Okay, we have our demand. Oh, first we're going to check, once again, before we do part C, we want to make sure we have good supply and demand functions. So I'm going to plug in. By the way, nothing, if you get this part wrong, everything else is going to be wrong. So it's important. I don't have any great checks for this, but it's important to get this part right. We'll take 16,000 times the other price, 0.625. It's always, so we use 0.5 to get this. Now we're going to use 0.625 minus 6,000. And we better get 4,000 from this, or we're wrong. And let's see what we get. We get 4,000. So that's a check. Now I can get to part C. Okay, so I believe in both this demand and the supply function. So I'm going to take my part C is the equilibrium where the demand and supply price generate the same quantity. So what is that? What is the price that I need to do? Is there. So we set the two guys equal to each other and find what P makes both quantities equal. Well, I'm going to get a little lazy here. I'm just going to do add 750 P and add 6,000 to both sides. Stop that. PP plus 6,000. So here, the 750 P's will cancel. Here, the 6,000s will cancel. And what we're going to end up with is 10250 is going to equal, because I know computer, 116,750 P. So if we take 1,250 and divide it by 16,750, that's going to give me about 0.61 is the equilibrium price. Now the same issue is going to be the equilibrium. To get the equilibrium quantity, we'll plug that in. Let's round that a little bit. It's 1, 2. Okay, it's not even, it's already rounded, but let's round it a little more. Okay, so I'm going to give it to the nearest tenth of a cent. Now at this point, we'll take the demand function and plug in 0.612. So for P, it's going to be times 0.612. Let's use American style. And it's going to give me is the equilibrium quantity. Unless we're wrong. Right? Let's check the work and see if it comes out right. So I'm going to use the supply function. And if I'm right, this should give us something equal or at least close to 33,791. So once again, I'm going to put in times 0. Again, I'm hitting the wrong key, 0.612. And the result, okay, within £1, that's close enough for me. So I'm going to call that a check. But let's say I didn't like that. I can go, this was the actual answer the gadget gave me. If I change this, okay, to the actual answer, I don't round, pretty much the same number, a little bit bigger. I change this guy also to the actual answer. Now, it is closer. So, if adding more digits makes it closer, then you definitely know that the error is from rounding. So this is pretty close. So if each time you add digits, it starts getting closer and closer, it's probably a rounding error. So I'm going to stop over here.